Linear inequalities. Inequalities are very similar to equations. An equation is a situation where you know that something equals something, but sometimes that's not what we know. Sometimes we just know that we have at least a certain amount, or at most a certain amount. And so in those situations, we are dealing with an inequality. So I have a table here to show you or remind you, if you have a certain symbol that's an inequality, what that symbol means, and then the way we represent that. The key thing to remember when you're solving an inequality is the rules are the same as equations, except that if you multiply or divide by a negative number, you need to switch the direction the inequality is facing. And that has to do with a very kind of technical math thing that basically you just need to remember, if I multiply or divide by a negative, flip the sign. So part A, on this example, we're going to solve the inequality and graph the solution set on a number line. And so I need to get my x's on one side and my numbers on the other. I recommend that for inequalities you always get your x's on the left. To me, it really simplifies things. So this is a situation where we would have moved to the left anyway, giving us 2x minus 6 is less than 1, and we add 6, 2x is less than 7, then divide by 2, x is less than 7/2. So on our solution set, our number line here, 7/2, if you wanted to really quickly find the decimal for that, that's 3.5. So halfway in between 3 and 4 is where our point is. You need to know, depending on your professor, how to draw it. Some professors will want you to use an open dot because we're not equal to, and then we would shade to the left because that's the direction of less than. The book that I'm using, or that we use at UCO, has a parentheses or a bracket instead of an open circle or a closed circle. And so because it's not equal to, we do a parentheses at 7/2, and then we draw to the left. The way I know which way to draw is think about your inequality as though it were an arrow, and that less than is pointing us to the left. So that's how I know to shade to the left. A couple other things it might want us to do is it might want us to write this answer in interval notation. And so to do that, remember negative infinity is over here, and we're going all the way to 7/2. But whatever we use here, since this is a parentheses, this is a parentheses, because all of these parentheses are saying that we're not equal to. Now, on this one, this is the situation where I said, to me, it's easier to move the x's over to the left. I'll show you what happens if we don't. I add 5x to both sides and get 12 is less than or equal to 14x minus 16. Then I add 16 to both sides and get 28 is less than or equal to 14x. Divide both sides by 14. And I get 2 is less than or equal to x. But that's not the way I want to leave it. An equation, that would be fine. But for an inequality, I want to flip this so that x is first, because in general, that makes more sense. 2 being less than or equal to x, how do I graph that? But if I rewrite it as x is greater than or equal to 2, I know how to graph that. So if we had just moved the x's to the left initially, that would have solved that problem. Although we would have ended up dividing by a negative, which is why our inequality would have flipped. So you might try it that other way just to see what happens. If we're graphing this, we need either a closed dot or a bracket at 2, depending on your professor. So we need a bracket at 2, and then we're shading to the right because that's the direction the inequality is pointing. And also think about it, which values are greater than 2? These values over here, right? So that's our line. As interval notation, we are going from 2 to positive infinity. We are equal at 2, so we do put a bracket.